Okay, chapter 7, we are going to start geometry, and that will go into chapter 8. So um, here at the beginning of chapter 7, we're going to go over some of the basics, and then we're going to build on it. So I feel like I say this every chapter, but it's really important that if you don't understand this first section, you are letting me know as soon as possible so that we can make sure we get you understanding it before we move on. So 7.1, we are going to classify angles. An angle is formed by two rays that share a common endpoint. The vertex is the point where the two rays meet. So if you think about an angle, this is a ray, and this is a ray, and they come together right here, and that is the vertex. So that's what those fancy words are saying, is that that's a vertex. Okay, so when we have a right angle, it is exactly 90 degrees. Now this should be review, but I'm going to go over it in case some of you have forgotten. We have 3 o'clock, and my lines aren't perfectly straight here, but if I had drawn it straight, 3 o'clock would be a right angle. It is a perfect square right there. Another time that might be a perfect right angle would be 6 o'clock. And not 6 o'clock, 9 o'clock. It's a perfect square right there. Okay, an acute angle is an angle that is less than 90 degrees. So there are lots of different times that you could do this. So I'm just going to give you a couple examples. So you could look at 1 o'clock being less than 90. You could look at 2 o'clock. And so forth. As long as it is less than that 90-degree angle, it is an acute angle. An obtuse angle is greater than 90, so that might be something along the lines of 4 o'clock, or go a little bit wider and make it 5 o'clock. This angle right here is greater than a square, that 90-degree angle creating a square. And a straight angle, here's where I was thinking 6 o'clock. A straight angle makes us a straight line. So it's two rays that backed up together cause a very straight line. Okay, here, this should be a little bit of review. Some of you may not have learned it. Two angles are vertical if they are opposite angles formed by the intersection of two lines. Vertical angles are congruent or have the same measure. So two angles are vertical if they are opposite angles formed by the intersection of two lines. So you look at this line and this line are creating 1 and 3 to be opposite from each other and 2 and 4 to be opposite from each other. So they are vertical. That means that they and the fact that they're vertical makes you know that they are congruent. So they have the same angle. So you can, if you see that 2 is, say, 110 degrees, you automatically know 4 is also 110 degrees. Two angles are adjacent if they share a common vertex, a common side, and do not overlap. So that might be 2 and 3, 3 and 4, 4 and 1, 1 and 2, and so forth. Name the angles shown at the right in 4 different ways, then classify it as acute, right, obtuse, or straight. So one of the ways that I can do it is I can just look at the vertex, and the vertex is y. So I can say angle y. So I can call it by its vertex letter. This 1 in here is saying that this is angle 1, so I could call it angle 1. This is the tricky option, and it is the more common option. This is what I'm getting ready to say. This is what you will use more in your high school geometry courses, and that is calling it x, y, z. with y being the vertex. So angle x, y, z, with y being your vertex. So your center letter is always your vertex. You could also do it as angle z, y, and x. So just doing it backwards. But again, your center letter is still your vertex. And then we look at this angle, and it is an acute angle. It is less than 90 degrees. 2A, identify a pair of vertical and adjacent angles in the diagram at the right. Justify your response. So I am going to, in red, do vertical. So the definition of vertical is that they are formed by two lines opposite of each other and congruent. So 1 and 3 would be vertical and congruent, and then 4 and 2 would be vertical and congruent. And I put that mark in it to recognize that 4 and 2 are the congruents, and then 1 and 3 are going to have 2 marks through it to show that they're a separate pair. And then I'm going to do adjacent in blue, go KU, and I'm going to have 4 and 1 are adjacent, so that's one pair of adjacent angles. Or I could have 2 and 3 are adjacent, or I could even have 1 and 2, and then I could also have 3 and 4. So lots of different ones that you could have there. 3A, what is the value of x in the figure? Because of vertical angles, I know that 2x plus 2 is equal to 130. So I can just say 2x plus 2 equals 130 because all vertical angles are congruent. So then I subtract 2 from both sides and I get 2x equals 128. Remember, this is solving for x like what we learned in chapter 6. Hopefully you remember it. If not, you might want to go back. If this is a two-step equation, so I think that was 6.4. I don't know. Two-step equations, whatever that is. And then to get x by itself, we divide by 2. So x is equal to 64. And I circle it, and that's my answer. Okay, 3b, we have the same figure, but now it's asking for the value of y. So we look to 3y minus 10, look across, and it has a vertical angle. So we know that 3y minus 10 is equal to 50. We add the opposite, so it's a negative 10. We add a positive 10. What you do to one side, you must do to the other. So we're left with 3y equals 60. To get y by itself, I divide by 3, and y equals 20. So I circle it, and that's my answer. Again, we knew that they equaled each other because we know vertical angles that are directly across from each other formed by two lines are congruent. So that's how we know that they are equal to each other.